Welcome back. So in this set of lectures, I'm going to be talking through the early years of artificial intelligence research. Of course, the exact point of origin of artificial intelligence research is debatable. Some of the contributions that we've looked at earlier and read about earlier could be counted as early contributions to the field. But the phrase or the term artificial intelligence comes into existence around 1956 in conjunction with a proposed project at Dartmouth. And so often this 1956 Summer Institute is held to really be the origin point of the field. That general line of research is going on under a number of different descriptions at this time. There are a variety of labels. For instance, Newell and Simon, some important contributors to the field, preferred the phrase complex information processing for a long time. But artificial intelligence eventually just kind of stuck as the label for this body of work that people were doing. And on this slide, I've included the names of some of the other conferences around this time that included many of the same participants as at the 1956 Dartmouth Summer Institute. One distinction that Nilsson builds his account of this period around is between symbol processing approaches and non-symbolic approaches. And we'll talk more about what was distinctive about each of those approaches in the rest of the videos here. I just want to point out briefly that this distinction between symbolists and other approaches to AI is still recognized today. One place where you see it is in Pedro Domingo's well-known distinction of 5 tribes of machine learning, basically 5 different approaches or ways of trying to solve machine learning problems. And you see here that symbolists are summarized, as well as, again, probably the most well-known among the non-symbolists is connectionists, what he calls connectionists. But at this time period, we will call them neural network researchers. And then there are a number of other options listed here too that we won't focus on in these slides, but we may return to talk about them later in the course. So what I'm going to do mostly is I'm going to look at particular AI models that were developed and proposed at this time. Sometimes I'll talk in a little bit more general way about approaches, that is, the kinds of techniques that were developed to use these models or the strategies and rationales behind these choices of models. But I want to look at a few examples of what might be called more specific model architecture. That is, exactly how a particular AI system was designed and what kinds of problems it was capable of solving based on that design. And an interesting feature here is that this was a time when people were very interested in asking what we could learn about human thinking from those machines and those systems, those models that were being built. And the assumption in a lot of AI research was that we can learn a tremendous amount about human thinking by building models that solve the same kinds of problems that so far only humans have been known to be able to solve, playing chess, for instance, or translating a language. Okay, and so the idea was if we could build a machine that can do those things that so far only humans have been able to do, and we think that humans are able to do it because of something about their minds, then those machines will reveal something to us about how human minds work. And so those machines and those programs, I should say. And so the issue of model architecture has a close connection with the question of what can be called cognitive architecture. The question of what is the structure of cognition? What is the structure of minds? How are they put together? What are their major working parts, for instance? And of course, those questions also connect with the question of what is intelligence? What is a mind? What is thought? And if we ended up, the idea was that if we ended up building artificial instances of these things, and we understood something about the mechanics of those artificial instances, then this would teach us not only about human thinking, but would teach us about thinking as such, right? So if we're interested in the nature of the mind, the nature of thought, the nature of intelligence, then these artificially intelligent systems can reveal a lot about that to us.